Today we have an episode that we enjoyed in a few ways. Not only did we get to talk with an impressive engineer from a firm we've read about since we decided to follow the structural path, but we get to talk about a really fun design space that has all the complexity of your most troubling project and a tenth of the area. We're talking with Travis of the MKA about entertainment spaces, performance areas such as stages, but also the reuse of older structures. I have a hunch if you're older than me at all, you've spent some serious time in malls. There are a lot of great podcasts about the history here, the social side, the economics. Malls were a huge part of our culture in the 90s, 80s, definitely earlier. These things are going back to the 50s. But what do we do with them now? Well, Travis has the experience to help owners think about this, and we get to hear the structural side. Let's see what we get to learn.
The Structural Engineering Podcast.
My name's Travis Corleano. I'm a principal at Magnuson Klemensic Associates, a structural and civil engineering firm in Seattle, Washington. At MKA, I'll refer to it. I lead our retail and entertainment team that encompasses a lot of different project types, but more or less means, right, I'm focused on places where people are actively choosing to go and wanting to take their friends and families. So I'm helping to create those spaces for them.
Yeah, that's wonderful. I know you do some really cool and unique projects, so I'm excited to talk about it a little bit. One question I want to start off with, when you get brought onto a project with a strong, unique architectural idea that might look really good in a magazine, the ones that we all love, what's your favorite kind of challenge to hear from the architect?
The best kind of challenge from really any engineer's perspective is going to be one that has a real strong design intent, right? Or a real strong purpose that it might be the architect or it might be the owner, but sort of that driving factor of why are we doing this or what are we trying to achieve here? So you want that really strong purpose, but then you also need a little bit of flexibility in how you get there, right? So as an engineer, we are very creative, but we're often not, creative with a blank slate. I always think about if you give somebody a blank piece of paper and you say, draw me a pretty picture, you give that to an engineer, they're going to stare blankly at the paper. Right? If you give them a piece of paper and give them 3 instructions of what you want them to draw, you're going to get a beautiful picture. So that's sort of the same bounds that we like to come into projects where the architect says we want to achieve this really strong vision, and the owner says we have this budget or roughly this timeline to do it, and now okay, we've got some constraints. Let's come together and figure out how to get it done.
What would you say are the common project types that you're working on? You kind of talked about retail and entertainment, but what does that actually mean or look like?
Yeah, great question. So the retail side of things, go back 10 years and we were still doing a lot of new ground up retail. At that time, it was focused on starting to do lifestyle centers or outdoor focused retail, which actually is making a comeback now. And there's a lot of outdoor focused new retail that's coming to life, or redevelopment of existing enclosed retail and trying to actually make it more outward facing, or carve up a mall and create more of an outdoor feel to that retail center. A lot of the retail work that we are doing now is in redevelopment of existing mall structures and existing anchor boxes, especially. There are just countless hundreds of empty anchor boxes out there. A lot of them are in pretty good prime real estate locations. So they're ripe for opportunity redevelopment. It's just figuring out what is the right use for those and how to make those pencil, because they can still be pretty costly projects. The flip side, the entertainment is something that we've really gotten heavy into the last few years as a result, partially of where the retail industry is, because the types of tenants that are filling retail spaces now are not your traditional large format box retailers. A lot of them are entertainment tenants or food and beverage tenants that require a different mindset of design than your traditional dry retail. So that led us down the entertainment road, and now our entertainment bubble includes live music venues. We focus on mid-size, 4 to 6,000 capacity venues. We just did the first 2 Netflix house projects that opened at the Dallas Galleria and King of Prussia. So those immersive experiences that they're kind of at the intersection of retail and entertainment. That's right where I live.
Oh gosh, I want to ask about the entertainment spaces because they're fun on purpose. So when we had talked before, you mentioned sometimes the complexity of a giant project can be represented in a small entertainment space, maybe like a
Mm-hmm.
stage.
Mm-hmm.
I'm sure there's a million details, but give us a little summary of like what sets a stage, what makes it unique. And I assume the loading is wild in every direction and
Mm-hmm.
rigging. How do
Yeah.
you even start this style of project?
Yeah. Concert venues are, in my mind, the single most critical project type to really understand the serviceability conditions or how that space is going to be used at the initial onset of design, right? Because it's you can't just design for the code level loads or the space is not going to perform well. When a concert venue works well structurally, nobody notices it. But if we get that design wrong, then the audience is going to feel that physically, right? Their insides are going to know if your vibration
Mhm.
criteria is not being satisfied. And so it's really important going into those projects that we do understand how those spaces are going to be used, where the dancing is going to be happening. More critically, are you going to have people sitting somewhere the dancing is not happening? Because those people sitting there are going to feel that motion more than the dancers. And when we start talking about rigging, that's a tough one because a lot of times you're trying to create a rigging grid for the tours that are coming in and they're going to be putting up their show lights, and you don't necessarily know what locations they're going to need, what loads they're going to need. So you're somewhat trying to create a grid that can handle a lot of different conditions. But at the same time, if you're too conservative and you're designing your structure for a high reading capacity over a large area, and that can really increase the cost of your structure. So all of these things are really important to dial in early with the owner and the architect so that we're really aligned with what criteria they want to hit, at what cost level are they trying to hit, and then we can go and we can execute the design for that.
Curious, and this is lightly touching the performance-based side, but do you design to a higher tolerance on some things? I know we're looking at a lot of probabilistic items when we have a live load count
Mhm.
and vibration concern in the like. Let's say if Zach and I did a workout room in a mall, like
Mhm.
I actually forget what this number is.
Forget what this number is.
So it's clear I don't have this memorized. I want to give a little data so you know where to go if you ever have this question. And really, if you do any commercial spaces over one story, run a little vibration analysis. In a square grid, these are easy numbers to hit, but a bouncy floor makes people feel uneasy, and we can do so much better. So ASC has a nice series, Facts for Steel Buildings, and number 5 talks about vibrations. I've only used the ASC Design Guide 11 principles, but there are a few papers you could reference. SJI, PCI, CRSI, and a few others all have handbooks for this. The natural period of your floor has several constants, but for the variables, it boils down to the square of EI over WL to the fourth. E probably isn't changing if you're at this point in design, so stiffer member will increase your natural frequency a little bit, but the length of bay will play a much stronger role. The tolerance limit for an office is generally 0.5% of gravity, but for Zach and my workout room in a mall, the tolerance limit may be as high as 10%. There's actually some fun reads, so pour yourself a big cup of coffee and enjoy. But we would just have this as a baseline and then it's fine. But
Mhm.
in a music space, things are really moving and like you said, people will feel it and be not be
Yeah.
very concerned. So yeah, do you drive this a little bit higher to what you actually expect to happen?
Vibration is a really interesting design problem because it depends so much on the input all around you, but also are you participating in that input, right? So if you are actively dancing, then you don't care if the floor is moving at 5 to 7% G. You don't feel that because you are participating in that motion. On the flip side, right, if you're sitting close but not participating, but you can see the people dancing, you might be willing to accept a 2 and a 2.5% acceleration. When I say percent, it's the percentage of gravity, which is how we kind of measure the vibration there. But you're going to have a lower tolerance, but you see that activity. You know why the building is shaking, and so you're okay with it. Now imagine you go behind a wall where you can't see that activity at all. You're just sitting at your desk typing away, and all of a sudden you start bouncing at that 2.5% G. You're going to be uncomfortable with that. You're going to say this building is falling down. What's going on here? because you can't see what it is that is causing that motion. So it's a perception that is very independent to each individual person too. What I might be willing to accept from a vibration standpoint might be very different than what both of you are willing to accept. And so all of the guidance out there, it's not a codified limit. It is guidance for targets that will generally be acceptable to most of the population. You may still have people that are sensitive to that level of motion, and really, as the structural engineer, what we're trying to do is limit the amount of complaints that the ownership team gets and educate them when they do get a complaint that it's not necessarily a structural issue, that it's, this is the condition why. But yeah, to go back to your original question a little bit, we will often do sensitivity curves on these seating bowls, and we can quantify at 7% acceleration maximum at the tip of a cantilever seating bowl what the steel tonnage of that seating bowl is. And then if we go back to 5% for the target, we know the delta. Maybe it's 100 tons of steel. And to go to 4%, it's another 100 tons of steel. So it becomes a cost versus performance decision that owner has to make. And we'll obviously provide our recommendations. We're never going to go and provide a seating bowl that we don't believe is going to be comfortable for everyone. But if an owner wants a higher performing bowl, that's something we can do. It's just going to add some steel, some cost to the project.
Would you say most of the owners you're working with are knowledgeable of that? I'm just curious, like that, when they own these concert venues, they understand the vibrations, or is that something you're coming in and educating them on?
It's really dependent. We do a lot of work with Live Nation, and over the last few years, they've done a really great job of actually creating some criteria manuals for people to follow. Now that came out of having some conditions where it wasn't super well defined, and they maybe didn't get the performance level that they wanted. On the flip side, if you go and work with a smaller owner, there's a lot of owners now that are doing venue spaces as part of entertainment districts outside of sports stadiums, and they may be, a lot of times they are associated with the sports stadiums, and so they understand the vibration as a part of a stadium function. But those can be very different than a live music concert venue where you're the sports stadium, everybody, you score a soccer goal, everybody's going crazy, right? That structure's moving, but it's more of a short duration there. And with the live music, a lot of times the rhythm, you're actually trying to get everybody in step, and you got to make sure it's not in the same frequency as that seating bowl, because you can get resonance, right? And you get that diving board effect where all of a sudden the bounces are getting bigger and bigger. And it might help some people dance a little bit better, but it might make some people a little more uncomfortable.
Man, yeah, things to think about that I'm sure many of our listeners, don't frequently think about when going to a concert venue or a stadium. I think those are
and those are, you think about code level loading and assembly loading 100 pounds a square foot, retail loading 75 pounds a square foot. You think about concert venues, and we design for a higher live load at the floor of those venues, because really, if there's ever a place you're going to get bodies smashed as tight as they can together, maybe people stacked on top of each other, it's at the stages of these venues. So it's another one where if you just open the code book, you might look at it and say, well, let's design this for 100 pounds a square foot, but you're probably under designing it for the actual use case. And then they also, the cavity or the volume of that space might be 50, 60 feet high. So how are you going to change the light bulb up there? Your floor's got to be able to accept some equipment that can drive on there and get up there and change that light bulb. So they're ones that the structure has to be designed smartly to really allow that operator to perform that venue for a good long duration. And the building only gets one chance to perform. And if it gets too bad of a rap from public perception, and it's not a place people want to go, well, you're not going to have a well-performing venue.
I'm curious. I think the time frame on this, and you'll see exactly as soon as I ask the question, is wrong. But have any venues had retrofits? I'm thinking music from the 1700s was very slow. Like, is there any update something a place moved to doing a lot of techno, and now they're seeing a vibration concern. I know this is an absurd thing,
Mhm.
but like I'm just curious if a retrofit in that style has you've seen.
Yeah, it's a real thing, and it is a lot of old-time theaters, right, that maybe it wasn't music at all, right? They were plays or performance establishments that went out of business, and now they're being brought back to life as these live music venues. Those oftentimes are not gonna have upper seating bowls that can really perform super well for a an active live music audience because, yeah, they were made for people to sit there and watch a show. Um, there's several different approaches to ways you can retrofit those. You can add additional structure or depth. It gets you a long ways when you're going with vibration. There's also different damping solutions where basically you're hanging weights, for lack of more technical terms, at the underside of the seating bowl that kind of counteract the bouncing. So not unlike a sloshing damper in a high rise tower where the bouncing is counteracting the motion of the venue. So these are things that are real world scenario conditions, and an ownership team or anybody going into an old theater retrofitting it to be a live music venue should be thinking about from day one. And it may be a condition where they are going to accept a higher level of vibration and accept the fact that some people are going to get uncomfortable. You can Google several of these, and people will take videos of the upper balconies, and you can see them moving. And those places stay open, and some people are uncomfortable, but most people end up accepting them for what they are. And you really, you're if you want to save the history of a nice old space, a lot of times you're going to have to compromise on something, and the vibration performance of an upper bowl might be something you're willing to compromise on to save the history and experience of a space.
To that same idea, are you designing new facilities for future flexibility? Is that a thought in how you're laying things out or designing the structure?
Yeah, future flexibility is a dangerous term, right? Because what you're really saying is that you're going to pay more money today for something that might happen tomorrow. So the answer is always yes. There's going to be some future flexibility built in, right? With the concert venues, we're talking about the rigging grid. That rigging grid is not going to be utilized 100% of the time. Some shows are going to come in and have 5 lights that they put up there, right? But you've designed the entire grid for a much higher capacity. So that is designing for future flexibility. This one really stings me in the retail side of my brain because I understand why a lot of the old retail spaces weren't designed for future flexibility, right? A lot of the retail stock that's out there, if it was built from the 70s to 2000s, it's built very efficiently for upper retail loading of 75 pounds a square foot. Nothing wrong with those buildings. They performed well. They performed fine. Now, when we go and try to put a restaurant in there, and that's a food and beverage that's triggering an assembly use, all of a sudden we have to retrofit the floor framing, columns, and foundations, all because we're going from selling T-shirts to a restaurant and bar. And you walk in that space and you really don't see that many more people or that much more load. And it's just something that we have to deal with. So nowadays, if we're doing new retail, I'm always going to have a discussion with the ownership group early on. And if they tell us to do a 75 pounds a square foot upper level retail loading, I'm going to provide them with some information and options of what it would cost them to upgrade that to 100 from day one. And it goes back to, again, that they can make the cost benefit decision, because if they want to spend a little bit more up front, that's their decision to make. As a structural engineer, it's not our money, so it's not really our decisions, but it is our job to inform the ownership of the limitations that they may be imposing upon themselves down the road.
Yeah, I think expressive architecture can make for some really fun design challenges. Is there any problem in a project that you've had that the answer felt unusually creative in a nice way?
Yeah, there's several. We were doing a retrofit of a 1940s garage here in Seattle, and it was an old timber truss structure with nail laminated roof boards, and the exterior was unreinforced masonry, and it wasn't falling apart, but it wasn't in great shape. And of course, all of those elements were landmarked, so we couldn't really touch them. We had to try to protect them, and we were trying to change that space from it was a garage and a kind of a retail space into a large um, food and beverage, large bar, which was a change of occupancy. So not only do we need to upgrade that space, but that change of occupancy to a higher risk category is sort of the highest level of upgrade where we have to bring it up to today's code, essentially. So that's a really challenging building to bring up to code without impacting all of these elements that were landmarked. So we were trying to add a second story to that building. Part of the existing building code, we had to reinforce the existing wood trusses. All of these things came together where we actually took some channels, stitched them around the old wood trusses, and tied them together as kind of latticed columns to go up, pop up through that roof truss and support the new upper level deck. And you walk through that space because it was this old, brick, the feeling of that space actually fits much better with those lattice steel columns than if you would have put in, a new steel wide flange or something in there. So it was something that it was costly, right? It's not something you would do if you didn't have to, but it was able to satisfy, three constraints in the project, fit the look and feel of what was trying to happen in there. And now that I walk through that space, I think those columns are super cool and they integrate really well with the roof. It looks like it's been like that forever. So that was one that worked out really well.
That sounds really cool. And I like that the structural side can be expressed. And yeah, it feels I occasionally been in old timber structures and oh gosh, what are they called? The CS straps of old days that were connecting timber across. Like it was bad at talking this day. Collar tie, tension tie bracket. I don't know if there's an official term that I'm still missing one here. So that's what I'm trying to talk about. It's like a problem that you do in a statics class under your first year. It's just very basic in a clean, well-designed way. Anyway, that's not the point of this conversation, but
Yeah, and now the industrialized look where you don't put ceilings in, you're not wrapping the columns, so you really see it all. And yeah, to your point on that one, right? We had to increase the wall anchorage so the wall doesn't rip off the diaphragm and fall back. And so there's all these straps going back. And you look up and you see that, but it's telling you a story, right, of how that wall is attached to the roof deck. And um, you know, you and I walk in there, we look up there and we enjoy it. 90% of the population that's going to a bar, they're going to the bar, getting their drink and, watching the TVs, not necessarily enjoying that beautiful structure up there, but it's there for them to enjoy if they see fit.
So it sounds like in the world of both entertainment and I mean, a lot of the work that you're doing has to in retail entertainment is very dynamic. I think about other kind of models or business lines necessarily that are more consistent. Would you say with what you're doing is you're kind of doing a little bit of everything, seismic retrofits to steel to concrete to timber to seems very diverse.
Yeah, it really is. And within our company as a whole, we have different market sectors that focus on specific things. And so, a high rise residential project here is going to be not the exact same, but you're using a lot of the same methodologies and design um, principles to complete those projects. And you get really good at one material, one design, and that's great. But yeah, to your point, the retail and entertainment breadth of projects that we are doing really requires us to understand so many different concepts, and it challenges us from a first principles of engineering that You got to be able to really get in the weeds, say, where is the load going? How am I trying to resist this load? I would almost step back and say, in our world, a lot of that engineering and design it's almost secondary to just understanding how is the space being used, where is the structure going to be hidden, where is it going to be exposed, do we need to really be focused on working through these details at the canopies or at feature stairs, or things that are going to make or break the user experience as they walk into this space, or what's going to leave them with the feeling that they want to come back here and that they're comfortable with that. So the structural engineering side of it is really important. But again, we're creating spaces that you want people to feel comfortable with and choose to go there and spend their money. And a lot of times, those spaces are created by combining the entire vision of landscape architecture, right? Wayfinding, all of those things. And the structural engineering is an important component of that. But we are really trying to make sure all of those things come together pretty seamlessly.
I want to change a little bit here and talk about the reusing malls, because I just think that would be also very fun and exciting challenge. What's the first thing you want to know when you have this style of project before you open up the drawings, just about the existing building and the plans for the project?
Well, the first thing to know is, are there existing drawings, right? It's amazing how far we can advance concepts or feasibility of how to reuse a space if we have even partial existing drawings. If you have no existing drawings and that space is built out from a previous tenant, we may not be able to really see much of anything structurally. And so I can't tell you what it's going to cost you to upgrade that space to a new assembly use and enhance the lateral system, because I don't know what the floor system is. I don't know what the lateral system is. And I can make guesses based on, previous similar building types or previous projects. But if we don't have some level of existing drawings, and if that building is not gutted so that we can really see the structure, it's really challenging for us to give good advice. Now, the adaptive reuse projects are really interesting because they always kind of turn us into detectives. So if we don't have those existing drawings at first, we're going to go to the city, look for them. We're going to go to the project site or the mall offices, look for them, do everything we can to find them. If we don't find them, then we're going to create testing programs or do some local demolition so that we can get just the bare minimum of information that we need in order to get a structural permit and get the construction crews in there to actually open things up for us. We're actually doing that process right now where we don't have existing drawings, and so within our drawing set, we're making lots of assumptions. We're stating those assumptions. Once they go and actually rip out the interiors of that space, contractor's going to have to work with us to validate all of those, and we're going to have to adjust the design based on what it is that they find. Most of the time in those projects, when you rip out the ceiling, you're going to find some skeletons in the closet, right? Old malls aren't really buildings; they're kind of archaeological sites, where as you dig deeper and deeper, you find previous generations of retrofits and things you didn't expect. So you really have to be ready to adapt to what it is that they find out in the field.
I know there was sort of a mall time where they're very popular. I don't know, but like 80s or something. Do you find that a lot of mall structures are very similar because of this, if they're all built in 10-year period, or am I just totally guessing incorrectly?
Well, there's a lot of the same concepts that each mall is following. And when we talk about malls, there's really two separate structures that we're talking about, because there's going to be the inline tenants and the actual malls and the concourses where you walk through and there's big skylights and the vendors in the middle of the concourses and all that. So that's kind of the main mall, we'll call it, right? And then there's the anchor boxes on the outside. And so when the malls were really thriving, it's when those anchor boxes were really driving the people to go to the malls. And so the anchor boxes were big. They had all the power. Actually, in their agreements with a lot of malls, they were able to write in, rights of refusal of other tenants and all these different things that even carry forward 20 years later. That anchor box might be defunct or empty, but they still hold those rights of refusal. They still have power over what can actually happen at the mall. So that's actually pretty challenging a lot of time for these mall redevelopment projects. But the main idea of some kind of concourse down the middle, right? Big, wide, open. If it's 2 stories or 3 stories, there's going to be that opening down the middle. There's probably some skylights down the middle. Those are going to connect at center concourses that have some sort of a feature, a moment there for people. And then branching off of all of those or most of those are going to be connecting to anchor boxes at either end. That main structure really holds true for majority of big malls in the US.
I'm curious if you go back a little bit and just, I think when we've talked before, we're talking about how the business of a mall even works, where that started and where it is today. Could you, walk us through that a little bit? I think that's fascinating.
Yeah, the malls they really are fascinating because as I mentioned, 20, 30 years ago, it was an arms race from the mall owners to try to get the anchors to come to their store and so or to their property. And so they would do, a lot to facilitate getting an anchor to come to their space. Now, majority of those anchors, and I guess let's take a step back too, because within the US, there was an expansion of retail and we overexpanded, right? We built too much retail space and there wasn't the demand for that. So while Amazon and all the internet shopping has, taken a bite out of the retail square footage that's needed, really we expanded too fast and there was never a need for as much retail space as we created. So what there's been a general acknowledgement of that within the industry. And what that has done is most of the big mall owners are reinforcing their top properties. They're making the really good ones even better. And they're kind of letting the B and C malls live out their days, right? See what happens with them. So those B and C malls, in theory, become great opportunities for overall redevelopment, right? These are locations that are oftentimes now surrounded. The cities have grown out and around them, so they've got really great populations. They're sitting there. They're maybe 15-acre site. You look at that and you say, "Wow, this should be, there's so much opportunity here." And I really believe that there is a lot of opportunity there. There's also a lot of capital required to adapt those entire sites, right? Somebody's got to be willing to put money into demolishing an old mall and regrading a site before they can do something totally different with it. And you're not going to get that money back, right? And so you do all that and then you build the new thing. Now you're putting more money in, which is, if you're looking at a 50-year horizon, Canada has kind of been better at this than us, where they're looking at long-term returns and development horizons, and so they're willing to put some more money up front, build some bigger buildings and bigger spaces for that long-term return. Where really here in the U.S. it's a lot shorter return time, and so it's hard to get those mega projects or the full mall tear down and let's replace this entire site with something else to go. Now they're happening, right? We're working on a couple, and I think over time there will be more and more of those opportunities because there's a lot of those properties out there, and it's just a matter of time till someone figures out how to make the dollars work. But we've seen some converted to college campuses. We've seen several that are being torn down and being converted to um, practice fields and arenas for different sports and entertainment kind of nodes, and then putting in some residential on the site as well. So there really is good opportunity there. There's a lot that goes into those projects. They're not easy to make pencil, and even if they do pencil, you got to get the city to buy off. You got to get the neighborhood to buy off. So lots of hurdles along the way.
Wow. Yeah, I think when we talked last time, it just blew my mind of how much control the anchor stores had and how those were set up, and it makes a lot of sense as thinking and growing up and thinking about like all the Sears or J.C. Penney's, and they own or they're in such big spaces, and probably to get them there having that control of what would come next. I mean, makes a lot
Yeah.
of sense.
Well, Sears is a fascinating story if you do a deep dive in the history of Sears, because really they did everything right in terms of they owned their stores, they owned the land that their stores were on, where a lot of the anchor boxes were actually just leasing the land. They didn't actually own it. And so when Sears went bankrupt, they were still left with all of this property. And there was a company, Seritage, that was redeveloping and working on what to do with those old sites, and they redeveloped some. We did the Abbey at Aventura is a project down in Florida that opened up just in the last few years. That was an old Sears site. The Sears got demolished and came back with a new outdoor retail lifestyle center, over a couple of floors of parking, and that opportunity only existed on that property because they had the rights to the parking and all of that area. Um, so really, not a lot of anchors have that full ground, the full area of ground there to work with, which also limits the ability to really redevelop those. And then you get the mixed owners, because somebody that owns the main mall may not actually own the anchor box, and multiple anchor boxes might be owned by multiple different people, and so it becomes a bit of a murky water when somebody wants to do something.
So is keeping those areas, focused on malls and retail, is that because of zoning, or is there any, reason just to tear it down and put housing there? Or is it that people are used to going to that location to buy things?
Mhm.
What is the focus there?
Well, it depends on the lens that you look at it through, right? So if you're looking at it from a city perspective, and a lot of cities that rely on sales tax,
Mm,
if you tear down an old mall and you build a residential community there, right, they're not getting any sales tax for that. And if you're trying to do a big mixed use development that requires additional sewage or additional water lines or things like that to that property, who is paying for those utilities to get to the site? So that's been a killer of several of our large projects, is that they realize that they don't have the infrastructure from a site utility standpoint to actually do what they want to do. And the cities, maybe they
mm,
are encouraging that development to go forward, but they don't have money to pay for those upgrades. And so the developer has to then decide, are they going to pay for all those upgrades? And oftentimes that cost again becomes a sunk cost at the front of the project. And those can really be killers when you're looking at trying to make something, return in 10, 15-year horizon.
yeah, that's a really good point. Do you find yourself that you get in there to these existing buildings and find that even just the loading is odd, or some, every space is designed differently, and you say, you know what, so retrofitting maybe the best thing is to, demo part of this instead of, reinforcing it, or let's use the spaces differently and trying to work with what's there, or, what's that dynamic look like?
Hmm. Yeah, there's lots of fun stories on old buildings, and as we're trying to adapt them, sometimes we are pleasantly surprised, and sometimes we are not pleasantly surprised. So I'll give kind of an example of both. We were doing the Netflix house at the Dallas Galleria, and we opened up we had existing structural drawings, and it was I forget exactly, but we'll say 3-inch concrete on 3-inch metal deck, typical steel frame system. We're like, great, we're going to be able to understand the capacity of this floor and retrofit it pretty efficiently, right? We dive into the details, and that building was built. Well, the design was completed months before a code change that took the steel studs that are on top of each of the beams from a 3-inch height to a 4.5-inch height. And so we confirmed in the field that they were designed with a 3-inch stud on a 3-inch metal deck. So if you look at today's code, they would say because you don't have that 1.5-inch overlap with the actual concrete topping, that those studs are basically worthless. That obviously would increase the amount of retrofit steel that we need to put in that building quite significantly. So we all of a sudden, to take it to assembly loading, if we said those studs had no capacity, we'd have to put infill beams in between each of the existing beams out there, and large WTs to strengthen the girders. We kind of did some math and talked to actually some professors that were doing some research, and we kind of had a hunch that even though the code said those studs were no good, that they are probably still doing what we wanted them to do. So we actually had them field load test 4 bays of that structure, and they went out there, right? They put 4 1.5-inch pavers on the floor, and then 50-barrel water drums on there, and they filled up the drums to different heights that would be equivalent loading. And so we were doing superimposed dead load plus live load with the load factors. So at the end of that testing, we were up to like 218 pounds a square foot of real load sitting on those 2 adjacent bays, and the structure was fine. Right?
Wow.
It barely deflected. There were some cracks that formed between the bays that were loaded and the ones that weren't, which made sense as the structure had to deflect some. But by code, we would have basically doubled the amount of steel in there. We did that testing. We didn't have to retrofit anything. So that's one that there was actually a moment where the contractor was really pushing to just put the retrofit steel in there because of time constraints. And I kind of had to stick my neck out on a call with the owner, and I basically said that's not the right decision. Like, I understand that there's a time consideration here, but you're talking millions of dollars of added steel. We should do this testing, and thank goodness that one worked out. I'm still talking to y'all here today. But, on the flip side, if you want to talk about finding some skeletons in the closet, because those are just as fun.
Yeah.
We're doing a project north of Chicago that we were adapting an old anchor box, and we walked around the inside of the building, and the exterior wall looked like a really nice CMU wall. It was, clean joints, everything looked good. So we were gonna, it was CMU with a brick exterior. The brick was gonna come off. We were gonna do some studs projecting off and some new glass to create a new exterior. So everything seemed like it was gonna be super easy and straightforward. They rip that brick off of the exterior, and what we find is that instead of an 8-inch CMU wall, there was actually a 4-inch finished interior wall, and then like chewing gum and chunks of rocks that were twisted every direction. There were half bricks that were twisted up. Like, they just took the remaining 4 inches cavity and filled it with whatever rubble they could find on the streets. And to make matters worse, then one of the contractors went and pushed on the wall, and it started wobbling, right? There was nothing actually attaching the whole thing in there. So that was a bit of a shock to everyone.
Yeah.
Not a great condition. And, it turned out we did some options. Well, how can we reinforce this wall? Can we still, do we think we can have the exterior attach into this rubble field of 4 inches? And it became pretty clear pretty quickly that that wasn't going to be a good long-term solution for the building. And so, it was fairly costly. Those CMU walls had to come down, and the new exterior walls had to get beefed up so they could span between floors. So it was a pretty big design change, not one the owner wants to see. But once everybody saw that wall, and we tried to find ways to save it, but at the end of the day, it was one that just it's the right decision to find the best long-term solution there, not necessarily the cheapest solution.
Yeah. As far as like solutions and cheap stuff, I have a question on going back to something you had said before when you're working with the architect. In this case, do you ever work with a developer when you're looking at like an adaptive reuse project to give an estimate of the cost? Because, the architect can say a lot, but a lot of this cost is held in the structure. And just to have a concept of what this might take way before we get involved in the project, on the architecture side, does that happen often?
Yeah, actually, the last few years, we've built some pretty good relationships with some of the big mall owners, and they will often call us and say, we're looking at adapting this anchor box here. Can you take a look and basically tell us where we have additional capacity or what are the upgrades that are going to be needed to work within this space? Because oftentimes, before you even have an architectural layout, right, we have something that's existing. There's a building here. Is it concrete framed? Is it steel framed? Are the exterior walls load bearing? Are they not? Is there a steel brace frame system? Once you understand these things, then you can pretty quickly find the opportunities to redevelop that building. For example, if you open up the drawings and you find load bearing exterior CMU wall that is part of the lateral system, is also supporting the gravity system, well, reskinning that entire thing with a new glass facade is going to be really challenging, right? Because you're ripping off the lateral system, you're ripping off the gravity system. Where vice versa, if you find a steel frame building with steel brace frames in there, and that exterior facade is maybe it's still CMU, but it's not structural, you can tear that thing off and put a new glass facade on the building without any impact to the existing structure. So we can find a lot of those things out without needing to really know what the program is. Now, there's the next layer of any redevelopment project, which is understanding what the program is going to be. And I really enjoy being at the table as those spaces or ideas are starting to be formed, because we can add quite a bit of value to a layout of a project, even if it's just helping people adjust things slightly so that it works better with the existing structure. So a couple examples of that, right? If you're trying to do a new elevator for a multi-tenant use, maybe it was a single use anchor box, you're going to split it into 4 tenants, so you need to add a new elevator in that space. Well, you can put that elevator up against a column, but if that column goes and is supported by a shallow foundation and you have to blast that elevator through that foundation, that might be really challenging. But if you can find a good spot, 10 feet away, where that elevator sits between columns, goes up, sits between framing, and essentially isn't cutting through any major structural elements, now you can just slice that elevator right through there, really at a economical structural retrofit.
My mind always goes to with developers, especially kind of led projects, is schedule. We talked about kind of budgets and focus on that, but what about schedules? How fast is your team executing these projects? And in my mind, a mall or even entertainment projects are fairly large. So is your team that you assemble fairly large, and the schedule very quick, I guess?
It ebbs and flows.
Okay.
So within MK as a whole, right, we have 160 structural engineers here, and so we can pretty easily scale up or scale down on a project as needed. The hope is just that all market sectors and all projects aren't scaling up at the same time, right? Which tends to work out pretty well. But it really, from my perspective, if I know the schedule and I know that the design intent is pretty well thought of, or there's a good concept or schematic plan that's not going to change significantly, we can be pretty dangerous getting stuff done pretty quickly. So a lot of these redevelopment projects, if we know what it is that the plan layout is going to be, so we know the new floor openings, we know the new exterior openings, and if that stuff's not going to change, right, we can go back and 6-8 weeks later have a pretty put together structural package for that, might be ready for permit. The challenge or the reason that we need these long durations on projects is often not structural. It is the ownership and the architecture teams figuring out how that space is actually really going to work. What are the tenants that are going to be coming in there? A lot of times the ownership teams, rightfully so, are going to want some pricing throughout the duration. before they continue to proceed forward. So we actually have a couple projects right now that the structural design schedule was compressed so much that we are delivering permit drawings before the owner ever had any pricing to them. And not unusual in today's market, that pricing comes back higher than they wanted. So, what happens now, right? Does the structure continue forward on the path that it was, and they're going to find that money somewhere else? Or, if you have to lop off an arm of a project, then, that's going to impact the structural design. So we may have to circle back and start doing some redesign. Now the project's already in permit, and so that can be pretty challenging.
I'm curious at MKA specifically, how do you guys, you're saying how many employees you have, over 100. How do you guys set up, projects? Are you leading all of the projects within this market sector? And then like from a staffing standpoint, utilize, younger staff from all over the firm and that work in maybe different market sectors? I'm just curious on that.
Yeah, it's a good question. So we have 13 different market sectors, and within those market sectors, there's generally going to be anywhere from 1 to 3 or 4 kind of senior engineers that are focused on those project types. So, our stadium team, we sit next to and we intersect a lot. They're doing sports arenas and football stadiums, and so a lot of the concepts they're using are live music venues are also using, but they are taking them up to a larger scale. So if we need to share younger engineers between there, we can, but we try to have a couple senior leaders that are really focused on the project types that we do. And it's amazing the value that really creates. We're talking about live music venues. I can come to the table during schematic design, and I know the acoustic requirements that are going to be needed on the exterior wall and at the ceiling of that space. And we're not acousticians, right? I'm going to be able to look at a seating bowl and tell you where the sightlines aren't going to work before anything's modeled in 3D, because I've looked at so many of these seating bowls, right? So being able to help guide the team on those early decisions, just because of the experience of having done these projects multiple times, is incredibly valuable. And it's the same for our high-rise office and convention centers and aviation airports. We specialize in those project types such that we can bring holistic project value, not just structural engineering input. But then, the younger engineers, we don't want to silo them into one market sector. And so we will intentionally, every couple of years, try to shuffle people around so that they have an opportunity to work with different project managers. They have an opportunity to work on different materials. One team might be very steel focused. One team might be very concrete focused. It's really important in my mind and in MKA's mind that those young engineers check off their list of design tasks and they get a holistic list, so that once they become a project manager, they can understand the building holistically and not just be an expert in the steel or not just be an expert in the concrete. They've got to be able to talk all the different materials, all the different connection types, all of that. So it's really important to move around a bit. And to be honest, different project managers, different market sectors are going to do things very differently. So an engineer that's in my team is going to see that I'm focused on very different things than if you're in other market sectors. My focus is a lot on how these buildings come together. We focus a lot on the mechanical coordination and understanding, are we creating rooftop mechanical zones that future tenants can come into, or are we giving them a certain location for that unit? Architecturally, we're going to be focused on canopies, storefronts, what are these details, things like that, where if you go work in high-rise office, you might be focused on very different things. And so it's good to get that holistic experience.
That will help a young engineer really learn quite a bit. I have a question sort of as a close down, but just to picture a project here, can you call out one project that really shows off your team's ability to produce something that looks really great against challenges or cost conflicts, like working through a problem well?
Yeah, one project that we're really proud of that's just finished up here in the last few years is Nashville Yards Parcel 9. So that's a project down in Nashville that was over 3.3 million square feet in total of building structure, right? It all came out of the retail entertainment team. It had a 12-story creative office building that has, I think, 8 floors of office, and then a movie theater, entertainment tenant, over a fitness tenant, over food and beverage. So, figuring out that stack, how do you make that work? How do you isolate the sound and vibration between all of those is really, there's lots of fun challenges there. That office building sits next to a 4,000 capacity live music venue that sits over restaurants. And then adjacent to that are two 33 and 34-story residential towers. So acoustically, right, you want to talk about having about as much acoustic challenge as you could on a site. All of those are packed pretty tight together. And then all of that is over 5 levels of below grade parking, which, if you ever do any work in Nashville, when you think of foundation designs in most places, right, you think of digging up dirt and pouring some large foundations to spread the load out. Well, the rock in Nashville is just so strong that you basically don't even need foundations. Your columns just come down and like sit in the ground, which is great for the column support, but to actually get 5 floors down into that rock, right, is a big effort, and the blasting through rock and all that. So then you've got to adapt the exterior of your building to where the rock actually is blasted to, and the extent of that zone. So that was a really technically challenging project because we had steel in the office building, steel in the venue, all over concrete podiums, and then the towers are concrete. So all the different material types there. We had long span PT beams. We had flat slab PT in the parking garage. So all the different materials you could possibly have, expansion joints running through all of the building. And on top of that, we had 3 different ownership teams and 3 different architects and 2 different mechanical engineers. And structurally, we were, tying all of that together. So lots of challenges there, just in communication path, handoffs between mechanical. Sometimes went great, sometimes didn't, and so we had some missing holes in our core walls that we had to punch down the road and things like that. So I learned a lot. I think my team learned a lot, and proud that that one is open now. All the buildings are open today.
Wow. That's certainly a fantastic project and something definitely to be proud of. That is really cool. Definitely 3 different uses, and stacking those different uses sure was very dynamic and challenging. Wow. What was the schedule on a project like that
That
for
was an
design and
interesting
construction?
one. Yeah, so we actually had taken the full design through permit drawings, and they started blasting the hole, and then the pandemic happened. And so they continued blasting the hole during the pandemic, but the rest of the project went on pause. And it came back after the pandemic, and there had been some shuffles in ownership, shuffles in architecture, and all of a sudden the project had actually grown quite significantly. So we went from, I think, a 5-story office building in one tower to the 13-story building and 2 residential towers. And we actually designed another component for a future uh, hotel or residential tower. So the building had expanded quite a bit. Um, from there, it was a year and a half design process after that, and then a couple of years of construction before everything was completed. So that one, to do something that big and coordinate all the different uses, um, those ones aren't going to happen quickly. Those are going to need to take their time.
Yeah. Well, what would you say, or is there any questions that we have yet to ask that you think would be really interesting for our audience with respect to entertainment and retail?
Ooh, good question. I guess, we never really touched much on the timeline of when we get engaged in a project versus, when the project might be conceptualized. And I would say a lot of challenges that we run into is if we get engaged on any of these projects too late. And if there's already been design that's shown to an ownership team that they fall in love with without understanding the cost or complexity that might come along with that, or if there's already been a budget that's established. And so we'll run across projects that have a square foot and a budget, but the ambition of that project and the square footage don't match the budget. So if it starts with a disconnect from day one, then as a design team, you're really pushing on rope to get that thing to work. So the timing of when we get engaged, we talked a bit about wanting there to be good design intent or ownership vision of what it is that they want to achieve. If we're able to start early in the process with that vision, then we can really help guide the process. But yeah, if we come in too late and a lot of those decisions are locked in place, then it can be really challenging if there's been some missteps or miscommunications kind of along the way.
I assume the entertainment space is much quicker than traditional construction, that you need to be upfront to help make the decisions because it's going to influence the structural choices later. It's a lot stronger than a steel building that's just a box.
Yeah, a good example of that is that we were doing a venue that actually is going to open this year, and we were given a seating bowl at the start of schematic design, and the 30 seconds into looking at that seating bowl cross section, I knew it didn't work. The rake at the top was not sufficient, so everybody at the top was looking through the structure in order to see the stage. And so from the second we were on board, we were kind of beating on the drum that this bowl doesn't work, this bowl doesn't work. But the ownership already had been told that this was the bowl design, and so they kind of wanted us to push it forward. And it wasn't until actually we got to the end of schematic design and we really were able to get everyone to sit and look at the bowl together that everyone acknowledged and understood it just didn't work. And so that, right, we're taking a step back in the project. We actually worked really well with the architect there to get that bowl to work. It's a totally different bowl than what was started with, right? That one had 3 tiers. We had to basically take the third tier, smash it down into the second tier to get enough rake for that to work. So pretty impactful in the overall programming of it. Worked out great. The seating bowl is really well done now. And I was just able to walk it a few months back, and there's not a bad seat in the house, which is what I'm always worried about when you do that. Because if you actually look at a lot of old venues, like the Grand Ole Opry, for example, you can buy a ticket where you're literally sitting right behind a column. Like there's a column in front of you, and that they sell that, and they call it, a view restricted seat or something like that. And you'll click on it.
Very cheap.
Exactly. Yeah, it's not. So my goal is that none of those things happen in any of my venues. And so when that first time you walk that bowl and you go around and you're looking at the sightlines, it's always a bit nerve wracking for me. But that one was one that could have gone really wrong if we didn't get everyone's attention and get that fixed.
I was thinking when you said that's probably the perfect seat for a structural engineer, just right behind the column. You're just staring at the structure.
The live music venues are great examples of actually having a lot of exposed structure, but really nobody ever notices it, right? Because they paint it all black, it's dark. If people are looking at our structure, then you got a really bad show going on. So you hope everyone's looking at the stage and the lights and the flashing and the smoke and the fire and all that. Nobody's looking up at the bolted truss connections above you, which is it's too bad. They're really missing out.
Yeah, the 1 in 10,000 or 100,000 people there that are structural engineers maybe are appreciating it. And I'm sure yourself, when you go to different venues across the world, even, you're probably admiring what they did or figured out. Or
I think it's a bit of a curse. Every building I walk into, the first thing I do is look up, right? And I'm trying to look at details and what's cool and what's not and what's working and what's not. So I think we're a special breed of the general public that's looking up. Most people are not.
Yeah. Well, to wrap us up here, what would you? A lot of our listeners are young engineers. They're either in college or the first 5 years, or maybe 7 years out of school. What's a piece of advice you'd give them for their career?
What I would say, and I think something that's made me really successful, is be really good at what it is that you decide to do. So there's a baseline level of, for me, if I'm doing retail entertainment structures, I have to be able to deliver on the structural design of those retail entertainment structures. But don't be afraid to expand your knowledge horizon beyond that. Kind of like I said, most of the value that I bring to these projects over other structural engineers that are going to be just as technically competent, right? They can design the columns and the shear tabs and the reinforcing connections. They can do everything I can do there. But where I can separate myself is really understanding how that space is going to be used. What are the tenant criterias that the tenants are going to need, so that we can help guide the owners to make sure they're creating a space that is good for those future uses. How is the mechanical system going to work? Where is the architectural detailing, interfacing with the landscaping or the exterior site paving, and how do all of those things come together? So don't be afraid to be a sponge when you sit in meetings with all these consultants. Really listen to what it is that the landscape architect is talking about. What do they care about and why? And you can carry that forward into future designs. And I think there's a lot of power in understanding that us as structural engineers, we are in the middle of a lot of these conversations. We're kind of the glue that holds a lot of these different consultants and trades together. So while it's the architect's job to truly bring all of those together, if you want to be a good partner to the architect and a good friend to that architect, make their job easier by being able to help and make smart decisions. Beyond that, I would just say, like I said, be really good at what you do. Try to do good in all of your designs. We're creating spaces for the general public. Create spaces that families and friends and people can go to and make memories. But more so than that, enjoy it, enjoy the ride, because these projects and our careers and everything ends up going a lot faster than you realize. So really take the time to uh, absorb the moments when you're in them, when you have learning opportunities, take those chances to really learn that. And when you have opportunities to step up and be a leader or show what take advantage of those opportunities.
That's fantastic advice. Well, Travis, thank you so much for being on the podcast. I know Max and I both learned a lot, and I'm sure our listeners will too.
Yeah, thanks for having me. This is great.